When we say that Einstein showed the power of imagination in scientific discovery, we're really saying that he transformed imagination from something people associated with poets and dreamers into a legitimate scientific instrument. Before Einstein, science was dominated by rigid rules, strict frameworks, and calculations rooted deeply in classical mechanics. Scientists worked within the boundaries of known laws and verified results only through observation or experiment. But Einstein did something radically different. He turned the laboratory inward into the mind. His thought experiments, those mental movies he crafted and played inside his imagination, became just as important as any real world measurement. He didn't need $1 million lab or exotic equipment. He needed curiosity, courage, and the ability to imagine scenarios no one had even questioned before. That shift in thinking alone changed the entire landscape of science forever. Einstein understood early in his life that imagination allowed him to explore beyond what was visible. As a child, he was fascinated by a simple compass. While most kids would enjoy the object for a few minutes and then toss it aside, young Einstein stared at it with almost spiritual wonder. He couldn't understand why the needle always pointed north no matter how he turned it. Something invisible, something mysterious, was guiding it. And that sense of an unseen force shaped his entire intellectual journey. He once said that the experience showed him there were deeper realities hidden beneath the surface of the everyday world. Even at that young age, imagination was already pulling him toward questions that the conventional education system couldn't answer. His school years are famous for showing the clash between structure and creativity. Einstein hated memorization and didn't care for rigid instruction. His teachers saw him as a poor student, but the truth was that his imagination resisted the confines of classroom expectations. When asked to solve a problem, he didn't want to follow the pre-written steps from the textbook. He wanted to understand why the steps existed at all. He needed to explore concepts from the inside out. This mindset is exactly what later allowed him to break theories that had been unchallenged for centuries. People often misunderstand imagination as something chaotic or unstructured, but for Einstein, imagination was disciplined freedom, the ability to wander intellectually while still preserving logical clarity. In adulthood, Einstein's imagination matured into a powerful scientific tool. Long before he had any access to advanced equipment, he was sketching incredible mental scenarios, riding alongside a beam of light, falling freely inside a sealed elevator, or watching clocks tick at different speeds depending on motion. These weren't just fun ideas. They were deeply philosophical questions dressed in simple imagery. When Einstein imagined riding on a light beam as a teenager, he wasn't just daydreaming. He was confronting a core puzzle. What would light look like if you moved alongside it at the same speed? Classical physics said you could catch up to it, but Maxwell's equations said its speed never changed. That clash between imagination and established science created the doorway to relativity. Without this imaginative leap, this mental visualization of an impossible scenario, relativity might never have been born. The true strength of imagination in Einstein's work is that it allowed him to break free of assumptions others never questioned. Most scientists assumed time was universal. Why? Because it seemed obvious. Time felt constant to human experience, and Newton's laws had baked that assumption into physics for hundreds of years. But Einstein's imagination didn't accept obvious answers. He imagined two observers moving at different speeds, each holding a clock. He pictured what they would see and what the universe would permit. By imagining the experience from inside the scenario, he realized that both observers could be correct about the passage of time, even if their clocks did not agree. That idea was shocking, but it was logical within the framework of his thought experiment. Imagination wasn't used here to create a fantasy. It was used to test reality in ways the physical world couldn't yet demonstrate. Relativity itself, special and general, was born almost entirely from thought experiments. Einstein's most famous one involved a person in free fall. He imagined that if someone fell inside an enclosed elevator, they wouldn't feel their own weight. For that moment, gravity would seem to disappear. But what if that disappearance wasn't a trick, but an insight into the nature of gravity itself? That simple mental scenario led him to the equivalence principle, the heart of general relativity, which eventually developed into the revolutionary idea that gravity isn't a force but a curvature. In spacetime, when you break it down, what he produced was not just physics. It was a story told through imagination that became a scientific theory supported by mathematics. Another aspect of Einstein's imaginative power was his ability to simplify the universe without trivializing it. He could take complex physical systems and reduce them to pure conceptual forms. For example, when thinking about the photoelectric effect, he imagined light behaving as tiny packets of energy. No one had ever visualized light like this. Quantum theory today depends on this simple yet powerful imaginative step. While others treated light as a smooth wave sweeping across space, Einstein pictured individual quanta knocking electrons free from metal surfaces like tiny unseen billiard balls. That image wasn't just poetic. It solved a real scientific puzzle and earned him the Nobel Prize. His creativity directly reshaped the foundation of quantum physics. One of the most striking qualities of Einstein's imagination is the way it embraced paradoxes. Most thinkers avoid contradictions because they create confusion, but Einstein saw them as gateways. When classical physics produced contradictions, like the incompatibility of electromagnetism and mechanics, Einstein didn't try to force them into agreement. Instead, he visualized new frameworks where both could exist without conflict. In a sense, imagination became his compass, guiding him into unexplored intellectual territory. And because he trusted that compass so deeply, he was willing to take risks that others avoided. This courage to imagine beyond the boundaries of accepted science was perhaps the most crucial ingredient in his success. Even Einstein's mistakes reveal the strength of his imagination. He introduced the cosmological constant because he imagined a universe that was stable and unchanging, a picture that later turned out to be incorrect. But he also had enough imaginative elasticity to admit his error and re-envision the universe after new evidence emerged. In a poetic twist, modern cosmology revived the constant as dark energy. His imagination was so rich that even its abandoned ideas turned out to contain seeds of future science. Einstein's imagination wasn't an isolated gift. It was deeply connected to his philosophy of science. He believed that true understanding required seeing the world not as it appears, but as it could be under different conditions. He famously said that imagination is more important than knowledge because knowledge is limited to what we currently know, while imagination embraces everything that might exist. In this sense, imagination becomes the engine of progress. Knowledge records what we have discovered. Imagination charts the map for what comes next. Einstein wasn't dismissing knowledge. He was redefining the relationship between the known and the unknown. Many scientists today continue to use imagination inspired by Einstein's approach. The concept of black holes came from imagining extreme gravitational collapse. Wormholes, time dilation, gravitational waves, These ideas were first explored through imaginative mental models before they ever entered equations or experiments. Even technologies that rely on relativity, such as GPS satellites, came from embracing Einstein's imaginative view of time and motion. Without those imaginative steps, modern navigation would fail entirely. In a very real way, Einstein imagined the world we live in today. But perhaps the most beautiful part of Einstein's imaginative power is that it came from a place of humility. He didn't imagine because he wanted to prove he was smarter than everyone else. He imagined because he was genuinely curious, because he wanted to understand how the universe worked on the deepest level. His imagination was an act of wonder, not arrogance, and that wonder infected generations of scientists who followed him. When young physicists today imagine particles tunneling through barriers or spacetime rippling like fabric, they are walking the path Einstein opened. His imagination didn't just create new science, it created a new culture of scientific thinking. Einstein also used imagination to connect science with humanity. He imagined peace in a world torn by conflict. He imagined a society where knowledge wasn't used for destruction. Even though he understood the power of nuclear energy through Mach formula, he worried deeply about how humans would use it. His imaginative empathy allowed him to see beyond equations into ethical consequences. This connection between imagination and moral responsibility is a part of his legacy that deserves just as much recognition as his scientific genius. His imagination was both analytical and compassionate, giving him a unique voice at the crossroads of science, philosophy, and human values. In the end, saying Einstein showed the power of imagination in scientific discovery isn't just a statement about his work. It's a statement about the potential of every human mind. He showed that breakthroughs don't always require fancy tools. They often require the courage to challenge what seems obvious, the creativity to visualize what has never been seen, and the patience to explore ideas that may initially feel impossible. His imagination turned the universe from a rigid machine into a dynamic, mysterious, and beautifully flexible entity. And that imaginative vision continues to shape every scientific field today, from quantum mechanics to cosmology. Einstein's genius often feels mythical, almost otherworldly, but when you strip away the legend, you're left with a human being who used one primary tool again and again: the ability to imagine situations far beyond ordinary experience. In Part A, we explored how imagination served as the seed for his greatest breakthroughs. In Part B, we go even deeper into how his imaginative method reshaped scientific culture, influenced the direction of future research, and ultimately demonstrated that imagination isn't just helpful. In science, it's necessary. His breakthroughs weren't accidents, and they weren't the result of inspiration alone. They were the outcome of a disciplined mind that used imagination with extraordinary precision. Einstein approached problems with a kind of mental flexibility that seemed almost magical to those around him. Most scientists in his era were trained to trust measurements and established theories. They believed the world could be understood by collecting data, interpreting graphs, and following the mathematics. Einstein respected mathematics and data, but he sensed something deeper. The universe wasn't merely a place to observe, it was a place to interpret. Imagination allowed him to reinterpret what everyone else accepted without question. When he looked at problems, he didn't see equations first, he saw stories, scenarios, possibilities. And these stories often revealed contradictions that equations alone could never expose. Take the example of simultaneity, a cornerstone of special relativity. Before Einstein, Scientists assumed that if two things happened at the same time, everyone in the universe would agree they were simultaneous. Einstein shattered that belief simply by imagining two lightning bolts striking opposite ends of a moving train. To observers on the platform, the bolts hit at the same time. But to an observer sitting inside the train, one bolt would appear earlier than the other because the train moves toward one flash and away from the other. This wasn't just a quirky idea. It was a profound reimagining of time itself. And yet, all Einstein did was use imagination to highlight something hidden, that the universe might not grant every observer the same perspective. His mental picture turned simultaneity from an unquestioned assumption into a relative concept, and that shift created an entirely new geometry of space and time. Imagination also gave Einstein the courage to pursue ideas that felt uncomfortable or even absurd to his peers. When he imagined that time moved slower for fast-moving objects, many scientists resisted the idea because it contradicted common sense. But imagination doesn't depend on common sense. It depends on consistency and logic within the imagined scenario. Einstein trusted his mental frameworks even when they felt strange. That trust allowed him to follow the implications all the way through, no matter how radical they became. And time dilation, once a bizarre idea, is now a measurable, proven fact of physics. His imaginative leaps weren't random. They were guided by a deep understanding of physical principles. He used imagination not as a replacement for mathematics, but as a guide for where mathematics needed to go. The math of general relativity is famously difficult, involving curved manifolds and tensor calculus. But Einstein didn't start with tensors. He started with pictures, a falling elevator, a beam of light bending near a massive star, a clock ticking slower in a gravitational field. These pictures helped him envision a universe where gravity wasn't a mysterious invisible force, but a geometric effect. Later, mathematicians like Marcel Grossman helped him translate these pictures into hard equations. Without imagination, the equations would never have existed. Without mathematics, the imagination would never have been proven. Einstein showed that imagination and logic aren't opposites, they're partners. One of the most underrated examples of Einstein's imaginative influence appears in his debates about quantum mechanics. Even though he contributed foundational ideas that helped birth quantum theory, he struggled with its randomness. His imagination wasn't satisfied with a universe governed by probability. He famously said, "God does not play dice with the universe," not because he was religiously rigid, but because his imaginative sense of harmony insisted that deeper laws must exist behind the randomness. Ironically, even his disagreements with quantum theory shaped scientific discovery. His imaginary thought experiments about entanglement, the EPR paradox, challenged the completeness of quantum mechanics. What began as an imaginative critique later became the foundation of quantum information science, quantum computing, and the modern understanding of non-locality. Today, entanglement is one of the most important concepts in physics, and it exists because Einstein imagined a scenario that pushed the theory to its limits. His imagination was also fueled by intuition, a soft, almost emotional sense of how things should behave. This intuition wasn't childish. It was the product of years of immersion in physical ideas. When he approached a new concept, he often said he felt his way through the problem. Instead of relying solely on analytical reasoning, he let his mind wander freely and then reeled it back in to examine the structure of his ideas. This balance between intuitive imagination and disciplined refinement created his signature style. His brain seemed to work like a two-stage engine. Imagination ignited the idea, and logic sculpted it into a theory. Einstein's imagination also flourished because he wasn't afraid of simplicity. While other scientists added complexity to solve problems, he stripped complexity away. He imagined basic scenarios that captured the essence of a problem without distractions. This minimalist style gave him an extraordinarily clear vision of physical principles. For example, he imagined two observers looking at the same event, but disagreeing on time because of relative motion. This single simple picture dismantled centuries of classical physics. Throughout his life, Einstein trusted the power of simple imaginative models, believing that nature often reveals its deepest truths in the most elegant form. And history proved him right again and again. Another way Einstein's imagination changed the scientific landscape was through his redefinition of what a scientific question could look like. Before him, scientific questions were often tied to experiments. How does this move? How fast does this fall? How much force is needed? Einstein's questions were different. They were philosophical in nature, but scientific in consequence. He asked, what is time? What is the nature of motion? What would the universe look like if I moved at the speed of light? These weren't typical science questions, yet they opened paths to discoveries no one had even considered. His ability to ask imaginative but precise questions pushed science into new territory and showed that the way we frame questions influences the discoveries we make. His influence extended into technology in ways he could never have predicted. Every GPS satellite in orbit functions correctly only because it corrects for time dilation, an effect he first imagined in his mind long before it was measurable. Without Einstein's imaginative breakthrough, your phone's location services would be off by kilometers. Similarly, lasers rely on quantum principles that Einstein helped conceptualize. Even the understanding of nuclear energy stems from the imaginative leap captured in E=mc2. Through his imagination, Einstein unintentionally shaped the world of medicine, communication, transportation, and even entertainment. It's wild to consider that a man sitting at a desk in 1905, scribbling ideas from thought experiments, ended up influencing the architecture of modern civilization. Einstein's imagination wasn't the stereotypical image of a scientist working in isolation. He had a rich inner world, but he also gained inspiration from music, philosophy, and conversation. Music, especially Mozart, played a huge role in his imaginative process. He said that if he weren't a physicist, he would have been a musician. When he played the violin, he often slipped into a state of creative flow. Ideas that seemed stuck suddenly loosened when he let his mind drift with the music. This blend of artistic and scientific imagination helped Einstein think in ways that transcended conventional categories. His correspondence with other scientists also reveals how imaginative his thinking was. He loved debating ideas, not in a competitive way, but in a playful, exploratory one. When he discussed theories with colleagues like Michel Besso, he would brainstorm scenarios out loud, inventing imaginary characters and situations to test physical principles. His imaginative energy was contagious. Many scientists walked away from conversations with Einstein feeling as though their minds had been stretched. Their understanding deepened, not by equations, but by the vivid conceptual worlds he created. Perhaps one of the most powerful lessons from Einstein's imagination is that it wasn't flawless. He made mistakes, changed his mind, and revised his beliefs, but he never regretted imagining boldly. Even when he realized he had been wrong, He saw those imaginative paths as necessary detours, parts of a larger search for truth. His mistakes weren't failures. They were experiments in the landscape of ideas. He trusted imagination enough to take risks and humble enough to correct course. This willingness to explore without fear allowed him to discover things no one else dared to consider. Einstein's imaginative power also influenced how he interacted with the public. He communicated complex ideas using simple metaphors: trains, elevators, clocks, beams of light. These images weren't just explanatory tools. They reflected the way he genuinely thought about physics. He believed that if an idea couldn't be imagined clearly, it wasn't fully understood. In doing so, he made science accessible to millions of people, inspiring generations who might otherwise have believed physics was too difficult or abstract. This democratization of imagination changed the culture of science education, making it more creative and less intimidating. In a broader sense, Einstein's imagination opened the door to modern cosmology. Before him, people imagined the universe as static and eternal. But when Einstein and later scientists applied relativity to the cosmos, they imagined expanding universes, contracting universes, curved universes, possibilities that earlier astronomers had never considered. Even the Big Bang Theory, which describes the universe's beginning, emerged from thinking within the imaginative structure that relativity provided. Einstein's imaginative world wasn't limited to local physics. It expanded to encompass the entire fate of the universe. Finally, Einstein's legacy proves that imagination is a universal human ability, not a luxury reserved for artists or a gift limited to geniuses. By using imagination as a scientific tool, he showed that creativity is just as essential in physics as it is in painting or music. He demonstrated that breakthroughs don't always come from collecting data or solving equations. Sometimes they come from daring to imagine something different, something contradictory, something new. His life reminds us that imagination isn't childish. It is a force that can reshape reality. Einstein's journey teaches us that the universe rewards imaginative minds. It rewards those who dare to ask unusual questions, those who play with ideas, those who refuse to accept limits too quickly. He proved that imagination isn't a step away from science. It's the first step. It's the spark that lights the fuse of discovery. When we say Einstein revolutionized physics with the theory of relativity, we're saying he performed one of the most dramatic intellectual transformations in human history. Before Einstein, physics was already a strong, well-built machine, a mighty structure crafted by giants like Newton, Galileo, Maxwell, and Faraday. Their work explained planets, motion, forces, electricity, magnetism, and the flow of energy. It was extraordinary, and for centuries it seemed untouchable. But Einstein looked at this great machine and noticed something subtle. A few gears didn't quite fit. A few assumptions didn't fully align. The universe whispered contradictions at its deepest levels, and he heard them. With relativity, Einstein didn't just fix a gear, he rebuilt the entire engine of modern physics. To appreciate this revolution, we have to step into the mindset of physics before 1905. People believed space was a fixed stage where events unfolded. Time ticked uniformly everywhere, a universal cosmic clock. If two observers measured something from the fall of an apple to the speed of a moving object, they might disagree on details, but time itself was sacred, absolute, beyond question. Light was known to travel incredibly fast, but scientists assumed it obeyed simple addition. If you ran toward a light beam, maybe the beam would approach faster. If you ran away, it would approach slower. Everything seemed consistent within Newton's world. But there was a problem lurking beneath the surface, a tension between Newton's mechanics and Maxwell's equations of electromagnetism. The speed of light 299, 792, 458 meters per second was predicted by Maxwell's equations, and it remained stubbornly constant no matter what you did. Experiments, especially the famous Michelson-Morley experiment, confirmed this bizarre result. Light didn't speed up or slow down relative to the observer. It just stayed constant, like a cosmic rule written into the universe. Physicists scratched their heads. How could this be? How could the speed of light be the same for everyone, no matter how fast or slow they moved? Enter Einstein. Instead of fighting that weird fact, he embraced it, and imagination lit the way. He imagined chasing a light beam as if he were riding beside it. If he moved at the speed of light, what would he see? Classical physics predicted weird nonsense, like a frozen wave of light. But Maxwell's equations said light always moves at the same speed, even relative to you. That paradox forced Einstein to confront the question, what if our ideas about space and time were wrong? What if the universe didn't bend to our intuition, but our intuition had to bend to the universe? This is where relativity was born, not from complicated equations at first, but from imaginative clarity. Einstein realized that if the speed of light was constant for all observers, then time and space themselves must be flexible. The universe wasn't rigid, it was elastic. It shifted depending on your motion, and once Einstein followed this idea to its logical conclusion, the barriers of classical physics shattered. He discovered a universe where moving clocks tick slower, moving objects shrink in the direction of motion, and the order of events can differ depending on the observer. This was not science fiction. It was the new architecture of the cosmos. The true power of special relativity wasn't that it made shocking predictions. It was that it explained the contradictions that had been haunting physics for decades. When Einstein published it in 1905, the world didn't immediately gasp in awe. Many scientists struggled to accept its implications. But slowly, with each passing year, the evidence mounted. Everything relativity predicted aligned perfectly with reality. Clocks aboard fast, moving jets ran slower. Particles in accelerators lived longer because time for them literally passed slower. GPS satellites needed corrections for relativistic effects, or they would misplace every location on Earth by kilometers. Relativity wasn't just correct, it was essential. Einstein's genius didn't stop at special relativity. That was just the beginning. 10 years later, he completed general relativity, one of the greatest intellectual achievements ever produced. To understand the brilliance of this theory, imagine the problem Einstein faced, gravity. Newton's theory, though powerful, treated gravity as an invisible force pulling objects toward each other. It worked beautifully for centuries until experiments and calculations started showing tiny discrepancies, especially in Mercury's orbit. Newton's theory couldn't fully explain those anomalies. Something was missing. Einstein returned to his imagination. He pictured a person falling in an elevator, feeling weightless. That experience revealed a deep truth. Gravity wasn't a force in the traditional sense. It was an effect of the geometry of space and time. Mass didn't pull. It bent spacetime, and objects followed the curves. This idea was shocking, elegant, and breathtakingly beautiful. Space wasn't a static background anymore. It was dynamic, alive, capable of stretching, curving, and rippling like a giant cosmic fabric. The sun didn't tug the Earth with a force. It curved the spacetime around it, and Earth followed that curve. With this insight, Einstein overturned the foundation of physics. His equations were so profound that they predicted phenomena nobody had even imagined: black holes, gravitational waves, expanding universes, time slowing near massive objects, and the bending of light around stars. When scientists observed starlight bending during the 1919 solar eclipse, exactly as Einstein predicted, the world recognized relativity as revolutionary. Newspapers declared Einstein a genius overnight. But the truth is, the revolution wasn't in the fame. It was in the fact that Einstein had changed how humanity perceived reality itself. Before relativity, the universe was a place of absolutes. After relativity, it became a place of relationships. Time wasn't universal. It was personal, depending on speed and gravity. Space wasn't fixed. It was molded by energy and mass. Motion wasn't simple. It was woven into spacetime. Einstein didn't just modify physics. He reimagined the entire structure of the universe, and every scientific field had to adjust to that new vision. One of the most powerful aspects of relativity is that it unified concepts that once seemed separate. Space and time became spacetime. Energy and mass became interchangeable through the equation E equals mc2. This equation wasn't merely symbolic. It captured a profound truth about nature. Mass is concentrated energy, and energy has mass. This insight unlocked nuclear physics, revealed the inner workings of stars, and explained why the sun shines. Before Einstein, the source of stellar energy was a mystery. After Einstein, nuclear fusion made sense. The stars above weren't eternal. They were engines powered by mass converting into energy, losing tiny amounts of mass every second as they burned. The light we see at night is Einstein's equation written across the sky. Relativity also changed the philosophical landscape. It shattered absolute time, reshaped our understanding of simultaneity, and introduced a universe where the past, present, and future might coexist in a four-dimensional tapestry. Einstein often said the distinction between past and future was a stubborn illusion, hinting at a deeper metaphysical picture suggested by relativity. His theories didn't merely reshape physics. They reshaped how we think about reality itself. What makes relativity even more astonishing is that Einstein developed much of it on his own, without the massive research teams common today. He worked in the Swiss patent office while producing some of the most groundbreaking ideas in history. He wasn't surrounded by expensive labs or advanced tools. He had pencil, paper, and imagination. His ability to look at the universe and see something completely different from everyone else is the essence of his revolution. He didn't just solve equations, he changed the rules of the game. Relativity's impact stretched far beyond Einstein's own lifetime. Today, it forms the backbone of cosmology. Without it, we wouldn't understand the Big Bang, black holes, neutron stars, or the accelerating expansion of the universe. General relativity predicted gravitational waves ripples in spacetime that were finally detected in 2015, a century after Einstein predicted them. It's almost poetic. Einstein imagined the universe rippling like water, and 100 years later, humanity heard those ripples pass through Earth. His imagination echoed across time, yet Einstein himself remained humble about relativity. He didn't think of it as a miracle. He saw it as a logical consequence of thinking clearly about contradictions in physics. But that humility hides the true magnitude of his achievement. He expanded the scope of physics to include the structure of space and time themselves. Before him, scientists studied what happened within space and time. After him, they studied space and time as physical entities. That shift was monumental. turning physics from a study of motion and forces into a study of the fabric of reality. Einstein's relativity didn't end debates. It sparked new ones. It raised questions that still challenge physicists today. How do relativity and quantum mechanics coexist? What happens at singularities? What is spacetime made of? These questions form the frontier of modern physics, and all of them trace back to Einstein's work. His revolution continues, echoing into the future. Relativity isn't just a set of theories. It's a new language of the universe. Einstein gave humanity a lens to see reality differently. He allowed us to measure time dilating, space bending, energy transforming, and gravity emerging from geometry. He showed us a universe that is dynamic, surprising, interconnected, and far stranger than classical physics ever allowed. Through relativity, Einstein didn't just change physics. He changed our relationship with the cosmos. He took us from a universe that felt predictable and simple to one that is richly textured, profoundly interconnected, and endlessly mysterious. He taught us that the universe doesn't obey human intuition. Human intuition must adapt to the universe. And that shift, that radical reimagining of space, time, energy, gravity, and motion, is why Einstein's theory of relativity is considered one of the greatest scientific revolutions ever achieved. Einstein's discovery of relativity did not simply adjust a few pages in physics textbooks. It forced humanity to face the uncomfortable truth that the universe does not work in the way our senses suggest. In the quiet aftershocks of his ideas, a new generation of thinkers realized that reality was not passive. It changed depending on how you moved, how fast you traveled, and even how you observed it. This realization had both scientific and philosophical consequences. It challenged old notions of destiny, fate, and absolute truth. If space and time themselves could bend, then what else was waiting to be discovered or reimagined? Einstein's own reflections show how deeply he wrestled with these implications. He often said that he did not invent relativity. He simply followed the logic of nature wherever it led him. That humility is striking when you consider how monumental the consequences were. But Einstein always felt as if he were standing at the doorway of something bigger. He viewed light not as a simple beam we could see with our eyes, but as a messenger carrying the secrets of reality. His obsession with light guided nearly every major discovery he made. In relativity, light acted as the universe's speed limit, the ultimate referee, the thing that remained constant when everything else bent and stretched. As physicists dug deeper into his equations, they uncovered predictions that sounded almost supernatural at the time. The existence of black holes, the possibility that time itself could slow down, and the idea that the universe could expand or shrink depending on the energy within it. These weren't added later, the seeds were all there, tucked inside his mathematics. Even Einstein did not fully believe some of his own predictions. He thought black holes were too strange to exist, and that the universe should be static, not expanding. It wasn't until Hubble's telescope observations that Einstein accepted the truth of cosmic expansion, a mistake he famously called his greatest blunder. Though honestly, it led to one of the greatest leaps in cosmology ever. The ripple effects of relativity extended far beyond astronomy. It inspired a scientific courage that had been missing for centuries, a willingness to break rules and explore unconventional possibilities. It opened the door for quantum mechanics to flourish, even though Einstein himself was hesitant to accept the randomness at the heart of quantum theory. The irony is beautiful. The man who dismantled classical physics and redefined reality became the biggest critic of the very theory that followed in his footsteps. His debates with Niels Bohr remain legendary, a dance of brilliance and stubbornness that shaped the entire direction of 20th century physics. But even Einstein's disagreements were productive. When he challenged quantum mechanics, he forced its defenders to sharpen their arguments, test their ideas more rigorously, and search for deeper understanding. His work on the EPR paradox, an attempt to prove quantum mechanics incomplete, ended up inspiring decades of research into quantum entanglement. Today, that same entanglement forms the foundation of quantum computing and quantum communication. Imagine that. A thought experiment meant to poke holes in quantum theory ended up becoming one of the most important ideas in modern technology. Relativity also influenced the way scientists thought about energy itself. E equals mc2, the most iconic equation in history, revealed that energy and matter were two sides of the same coin. This wasn't just some neat piece of trivia, it was a bombshell. It explained why stars shine, how nuclear reactions work, and how the tiniest change in mass could unleash unimaginable power. The equation reshaped astrophysics, chemistry, engineering, and even philosophy. Its implications reached into geopolitics as well. The same equation that explained starlight also paved the road to nuclear weapons, a twist Einstein neither intended nor endorsed. Yet, despite the dark uses of his discoveries, Einstein remained committed to the idea that scientific truth was a force for good. He believed knowledge should elevate humanity, not destroy it. This moral compass made him not just a scientist, but a symbol, someone people turned to for guidance in turbulent times. As relativity became mainstream, Einstein himself became a global icon. His wild hair, his playful smile, his thoughtful eyes, people saw not just a scientist, but a philosopher of the cosmos, a man who held the universe gently in his mind. The true weight of his contribution to reality becomes clearer when we consider how relativity reshaped daily life. Your GPS works because satellites orbiting Earth are running on clocks affected by both speed and gravity, exactly as Einstein predicted. Without relativistic corrections, GPS would be off by kilometers. Time dilation isn't sci-fi. It's something your phone uses every day without you noticing. Particle accelerators rely entirely on relativity. Advanced medical scanners, nuclear power, cosmic simulations, and even the timing of financial networks all depend on it. Einstein envisioned a universe connected by deep, elegant laws, and his work continues to connect our world in ways he never could have predicted. Even more remarkable is the emotional, human side of relativity. When he realized time and space were not fixed, Einstein felt it gave comfort to anyone who feared loss. If time could flex, maybe the distinction between past and future wasn't as absolute as we think. He once wrote in a letter that for physicists like him, the death of a loved one was less tragic because the separation was only an illusion. All times coexist, and the person still lives in another moment of the universe. This wasn't just physics. It was his way of understanding grief, memory, and love. Relativity wasn't only a theory. It was Einstein's philosophy of existence. By the time the world fully grasped his ideas, Einstein had already moved on to new puzzles, always searching for deeper unity. But relativity remained the foundation on which modern physics stood. It was the spark, the reset button, the door to the next century of discovery. Without relativity, modern cosmology would not exist. Without Einstein's courage to question the obvious, we might still be trapped in an outdated view of reality. His second keynote, The Remaking of Space, time, and reality was not simply a scientific milestone. It was the moment humanity realized the universe was stranger, softer, more flexible, and more poetic than we had ever imagined. We learned that truth could bend without breaking, that the cosmos could stretch endlessly, and that time itself could flow differently depending on how we move through it. Einstein didn't just rewrite physics, he rewrote our place inside the universe. Einstein's third transformative contribution to humanity was not merely a new set of equations or scientific theories. It was a profound reshaping of how we understand the very fabric of existence. Before Einstein, space and time were viewed as separate, rigid, and absolute structures. They were seen as the unchanging stage on which all physical events unfolded. Newton's majestic world, you had dominated science for more than 2 centuries, painting the universe as a grand celestial machine functioning with perfect predictability under fixed laws of motion and gravitation. But Einstein, with his daring imagination and ability to question the unquestionable, dismantled this centuries old foundation and replaced it with a universe far more dynamic, interconnected, and astonishing. The revolutionary vision Einstein introduced began with a simple but powerful idea. The laws of physics must be the same for everyone, no matter how fast they move, and the speed of light is constant for all observers. At first glance, these statements might sound harmless, even innocent. But when Einstein followed their logical consequences, the entire structure of classical physics began to crack. Space and time, previously seen as universal and absolute, were shown to be flexible and relative. Einstein demonstrated that measurements of distance, duration, and even simultaneity were not independent truths, but depended entirely on the observer's motion. This realization broke the illusion that time flowed identically for all people. In Einstein's universe, 2 observers traveling at different speeds experience different realities of time. The faster one moves, the slower time passes for them, a phenomenon now known as time dilation. This radical concept was not just philosophical. It has been measured repeatedly, from atomic clocks on fast, moving aircraft to particles speeding through accelerators. Einstein's vision rewrote our understanding of aging, motion, and the progression of time itself. It implied that there is no universal now, no single clock ticking uniformly across the cosmos. Instead, time is woven together with space into a single 4-dimensional continuum called spacetime, a concept that did not exist before Einstein brought it into the world. But Einstein's vision did not stop at merging space and time. He went further, showing that gravity was not a force pulling objects together, as Newton had believed. Instead, gravity was a curvature of spacetime caused by mass and energy. A planet orbits a star not because it is being pulled, but because the star bends the spacetime around it, and the planet follows the straightest possible path within that curved geometry. This idea, captured beautifully in Einstein's general theory of relativity, completely transformed the scientific landscape. The universe was no longer a static arena. It was an active participant, shaping and being shaped by everything in it. Einstein's revolutionary perspective redefined our understanding of the cosmos. It predicted astonishing phenomena long before they were observed. Black holes, where gravity becomes so strong that nothing, not even light, can escape, gravitational waves, ripples in spacetime produced by massive cosmic events, and the expansion of the universe, which later became the foundation of modern cosmology. These were not mere theoretical curiosities. Decades after Einstein's predictions, astronomers detected black holes, physicists measured gravitational waves, and scientists mapped the expansion of the universe. all affirming the depth and foresight of his vision. His reconceptualization of space and time also changed our everyday lives. Modern technologies such as GPS rely on corrections made using relativity. Without Einstein's equations, your navigation system would accumulate errors of several kilometers each day. Even the synchronization of communication networks, satellite systems, and scientific instruments depends on the relativistic understanding that clocks run differently under varying speeds in gravitational conditions. Einstein's ideas are embedded in the foundation of our technological world, proving that even the most abstract scientific concepts can become indispensable to ordinary human activity. But the true beauty of Einstein's vision lies not only in its scientific accuracy, but in its philosophical depth. He revealed that reality is far stranger and more elegant than our senses suggest. Space bends, time stretches, light curves, and the universe itself is dynamic and evolving. This opened countless pathways for new scientific exploration and inspired generations of thinkers to look beyond the limits of intuition. Einstein taught the world that nature is not obliged to conform to human expectations, only to truth. Moreover, Einstein's transformation of space and time reshaped our understanding of human existence. If time itself is relative, if motion alters the passage of seconds, and if gravity molds the shape of reality, then the universe becomes a living, breathing structure, one full of mysteries that invite curiosity rather than dogma. Einstein's approach encouraged humanity to question deeply and imagine boldly. For him, the universe was not a rigid machine, but a cosmic symphony governed by elegant mathematical rhythms. This keynote also reflects Einstein's unique style of thinking. Unlike many scientists who rely heavily on equations or experiments, Einstein often began with vivid mental images, what he called thought experiments. He imagined himself chasing a beam of light. He pictured clocks ticking on fast, moving trains. He visualized elevators in free fall and objects floating weightlessly inside them. These simple images, almost playful in nature, allowed him to uncover profound truths about the universe. His genius lay not merely in solving equations, but in asking questions that no one else dared to ask. Einstein's revolutionary vision continues to shape modern science. Every new discovery in astrophysics, cosmology, and quantum theory stands on the foundation he built. Concepts such as wormholes, time travel, the curvature of spacetime, and the behavior of light around black holes trace their origins to Einstein's timeless insight. Even today, as physicists search for a unified theory that merges quantum mechanics with gravity, they continue to follow the paths Einstein opened. Ultimately, this keynote captures the essence of Einstein's greatest gift to humanity, the ability to see reality not as it appears, but as it truly is: flexible, interconnected, mysterious, and governed by principles far more astonishing than everyday experience suggests. His work shattered the boundaries of classical thought and invited humanity into a universe where imagination and science walk hand in hand. By redefining space, time, and gravity, Einstein reshaped not only physics, but our entire understanding of existence. His vision remains one of the most profound and transformative achievements in human history. Einstein's fourth great turning point in reshaping the universe wasn't about confirming what he already believed. It was about wrestling with an idea he could not accept, one that grew into the most powerful and controversial scientific debate of the 20th century. This keynote is all about Einstein's confrontation with quantum mechanics, the strange, unpredictable world of the very small, a world that even he helped create, yet never fully embraced. His opposition, his questions, his doubts, and his philosophical resistance did not weaken science. Instead, they strengthened the entire field and pushed quantum physics to evolve into a discipline far deeper and more robust than it would have been without him. This struggle began with a problem so small it could barely be seen: light. Einstein's work on the photoelectric effect, which earned him the Nobel Prize, showed that light behaved like packets of energy, not just waves. These quanta were the seeds of quantum theory. Ironically, Einstein helped open the door to the very field he would later criticize. But once quantum mechanics grew beyond those early steps and began describing electrons, atoms, and subatomic behavior with new mathematical rules, Einstein felt something was deeply wrong. Quantum mechanics claimed the universe was not deterministic, that at the smallest scales, events did not happen for specific reasons but unfolded as probabilities. Particles didn't have definite positions until observed. Outcomes weren't fixed. They happened by chance. This was a universe ruled by randomness, by uncertainty, by unpredictability, and Einstein could not accept such a universe. He famously declared, "God does not play dice with the universe," a poetic rejection of the idea that nature functioned through pure probability. For Einstein, the universe was elegant, harmonious, and governed by deep laws, not chance, so he pushed back. He questioned everything. He challenged the founders of quantum mechanics, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, and others, in a series of debates that shaped the entire direction of physics. These debates were not mild disagreements. They were intellectual battles at the highest level, a clash between two worldviews. Bohr argued that quantum mechanics didn't describe hidden truths. It described what could be observed. He believed uncertainty wasn't a flaw. It was the truth of nature. Einstein fought against this idea relentlessly, insisting that quantum mechanics was incomplete, that something deeper and more fundamental must exist beneath the uncertainty. Their exchanges became legendary. Conferences would pause mid-session as Einstein unveiled a new paradox meant to break quantum theory. Bohr would go silent, pacing back and forth, thinking intensely. Hours later, he would return with a counter-argument. Sometimes Einstein won the day, sometimes Bohr did, and each time the debate pushed physics further forward. Einstein's most famous challenge was the EPR paradox, named after Einstein, Podolsky, and Rosen. It introduced the concept of spooky action at a distance, a phenomenon that suggested two particles could become linked in such a way that measuring one instantly affected the other, even if separated by vast distances. To Einstein, this was impossible. Nothing, not even information, should travel faster than light. Quantum mechanics, he argued, must be missing something. He believed there must be hidden variables, unseen factors that determined outcomes we simply could not yet measure. But instead of disproving quantum theory, the EPR paradox ended up sparking decades of groundbreaking research. Physicists like John Bell developed experiments to test Einstein's objections. To Einstein's surprise, long after his death, the experiments showed that quantum entanglement was real. The universe truly was interconnected in a way that defied classical intuition. Quantum mechanics wasn't broken. It was deeper, stranger, and more astonishing than even its founders imagined. Einstein's resistance played a crucial role in shaping all this. His challenges forced quantum physicists to strengthen their theories, refine their mathematics, and investigate deeper truths. Without Einstein pushing back so hard, quantum mechanics might have settled into a comfortable but incomplete form. Instead, it became sharper, clearer, and more profound. His skepticism was not a barrier, it was a catalyst. And here's the beautiful irony. Today, entanglement, the very thing Einstein doubted, is the foundation of quantum computing, quantum encryption, and emerging technologies that could reshape the future. His criticism became the fuel for the breakthroughs defining the 21st century. But Einstein's refusal to accept quantum randomness wasn't stubbornness, it was a philosophical commitment. He believed in a universe governed by order, coherence, and comprehensible laws. He sought a deeper unity, a theory that would connect electromagnetism, gravity, and quantum behavior into a single framework. His dream of a unified field theory consumed his final decades. Even though he never completed it, his pursuit inspired future generations of physicists searching for the ultimate equations describing everything from string theory to loop quantum gravity. What makes this keynote so powerful is that it shows a different side of Einstein, not the triumphant genius who rewrote space and time, but the relentless thinker who refused to accept incomplete understanding. A man who believed that truth was worth fighting for, even when he stood alone. A scientist who valued clarity and logic over popularity or consensus. His debates with quantum physicists were not fueled by ego, but by a deep desire to protect the integrity of science. This keynote also reveals Einstein's emotional side. His discomfort with uncertainty wasn't just intellectual, it was personal. He saw the universe as a place of profound beauty, structured by elegant laws. The randomness of quantum mechanics felt chaotic, almost disrespectful to that beauty. His resistance was emotional, philosophical, and scientific all at once, a rare combination that shaped some of the most important conversations in the history of physics. Einstein's engagement with quantum mechanics did more than shape scientific theories. It shaped the culture of science. It taught scientists to challenge boldly, to question everything, to never accept a theory simply because it works. It reminded the world that science grows through disagreement, through debate, through the collision of ideas. And it showed that even geniuses can doubt the very fields they help create. In the end, Einstein's fourth keynote, his wrestling match with quantum mechanics, stands as one of the most important intellectual confrontations in human history. It highlights his courage, his integrity, and his uncompromising pursuit of truth. It proves that even opposition can be a form of creation, and that science advances not only through discovery, but through challenge. Einstein may not have accepted the full strangeness of quantum mechanics, but his struggle shaped the field more than acceptance ever could. Albert Einstein is often celebrated for his abstract theories of space, time, and energy, but the true breadth of his influence extends far beyond the realm of theoretical physics. The fifth keynote focuses on how Einstein's discoveries have permeated our daily lives, transforming technology, communication, medicine, and even global navigation systems. This keynote emphasizes that the genius of Einstein is not confined to academic journals or the annals of science history, but is alive in the tools, technologies, and conveniences that millions of people rely on every day. Understanding this aspect of his legacy makes the accomplishments of Einstein tangible, relevant, and deeply human. One of the most significant contributions Einstein made to modern technology stems from his groundbreaking work on the photoelectric effect. Although this discovery earned him the Nobel Prize in Physics in 1921, many may not realize its practical implications. The photoelectric effect demonstrated that light could be understood as discrete packets of energy, or photons, which could knock electrons free from atoms. This discovery laid the foundation for the development of solar panels, photocells, and countless devices that rely on light detection and conversion into electricity. Today, solar energy is a rapidly growing industry, powering homes, businesses, and even spacecraft. Every time sunlight is converted into usable energy, Einstein's insights are at work, bridging the gap between theoretical science and sustainable technology. Equally transformative is Einstein's influence on the development of semiconductors and electronics. His understanding of energy, light, and matter informed subsequent research that eventually led to the invention of transistors, microchips, and computers. Modern electronics, from smartphones to laptops, from LED displays to complex medical imaging devices, owe a debt to the theoretical framework Einstein helped establish. While it is easy to attribute these advances to more recent scientists or engineers, the fundamental principles he uncovered provided the bedrock upon which these innovations were built. Without his insights into quantum behavior and energy transfer, our digital world as we know it would be markedly different, perhaps even unimaginable. One cannot discuss Einstein's impact on technology without mentioning GPS, Global Positioning System. Many people use GPS daily without considering the profound physics involved. GPS satellites orbit Earth at high speeds and experience weaker gravitational fields than objects on the planet's surface. According to Einstein's theories of special and general relativity, time is experienced differently under these conditions. Clocks on satellites tick slightly faster than those on Earth. Engineers had to correct for these relativistic effects to ensure the accuracy of GPS systems. The fact that your navigation app can provide precise directions, whether you are driving in a bustling city or hiking in a remote wilderness, is a direct application of Einstein's work. It is a striking example of how abstract concepts of time and space have been translated into practical, life-altering technology. Beyond energy and navigation, Einstein's theories have also revolutionized medical imaging. Technologies such as MRI, magnetic resonance imaging, and PET positron emission tomography scans rely on principles of quantum mechanics and energy interactions that trace their intellectual roots to Einstein's work. MRI machines, for instance, exploit the magnetic properties of atoms and the way they respond to energy inputs concepts directly tied to the quantum framework Einstein helped establish. PET scans use radioactive tracers, which involve understanding energy release and matter interactions at a subatomic level. These devices allow doctors to diagnose illnesses with unprecedented accuracy, detect tumors in their earliest stages, and monitor the effectiveness of treatments. Einstein's theoretical contributions thus directly improve quality of life, demonstrating the intimate connection between pure science and human welfare. The influence of Einstein's work extends into communications as well. Lasers, for instance, rely on the principle of stimulated emission, a concept Einstein proposed in 1917. Lasers are now ubiquitous. They read barcodes in stores, enable HICE, feed internet through fiber optics, perform delicate surgical procedures, and even drive precision manufacturing. Each of these applications reflects the long journey from Einstein's theoretical insights to technologies that are now woven into the fabric of modern society. By imagining possibilities in physics that others might have dismissed as abstract or impractical, Einstein set in motion a cascade of discoveries that transformed how humans interact with the world. Furthermore, Einstein's legacy is evident in astrophysics and space exploration. Instruments that observe distant galaxies, black holes, and cosmic microwave background radiation operate on principles he either predicted or inspired. Technologies like radio telescopes, X-ray observatories, and particle detectors all benefit from Einsteinian physics. Understanding the universe at both macroscopic and microscopic scales enables scientists to design spacecraft navigation, plan missions, and even predict potential hazards from cosmic events. Einstein's work thus bridges the cosmic and the human, reminding us that theories about the fabric of the universe can have tangible effects on exploration and knowledge. Equally important is the cultural and intellectual legacy Einstein left behind. His work inspired generations of scientists, engineers, and thinkers to push boundaries, question assumptions, and pursue knowledge for its own sake. The ethos of curiosity and rigorous inquiry that Einstein embodied continues to shape innovation in fields as diverse as biotechnology, quantum computing, and artificial intelligence. In essence, the technological advancements we benefit from today are as much a product of the mind that he instilled in humanity as they are of the specific equations he formulated. In conclusion, the fifth keynote highlights a side of Einstein often overlooked: the tangible, practical, and everyday implications of his discoveries. From solar panels and smartphones to GPS navigation, medical imaging, and laser technology, Einstein's genius is embedded in the tools and systems that define modern life. His work exemplifies the extraordinary power of theoretical science to create real-world impact. By connecting abstract ideas with practical applications, Einstein transformed not only our understanding of the universe, but also our ability to interact with it in profound ways. His legacy is not confined to textbooks or historical archives. It lives in the technologies we rely on, the systems we navigate, and the conveniences we often take for granted. Einstein's genius did not merely change the way we see the universe. It changed the way we live in it. Albert Einstein was not only a revolutionary physicist, but also a profound thinker whose ideas transcended the boundaries of science. The sixth keynote focuses on his philosophical insights and the broader impact they had on our understanding of reality, knowledge, and the very nature of existence. Einstein's reflections on science, truth, and human responsibility reveal a mind that sought not just to understand the universe mathematically, but also to grapple with its deeper meanings and moral implications. His philosophy continues to inspire scientists, educators, and society at large to approach knowledge with curiosity, humility, and ethical consideration. From a philosophical standpoint, Einstein was deeply committed to the notion that the universe is governed by universal laws that can be discovered through observation, reason, and imagination. This belief underpinned his entire scientific career, including his development of the theories of special and general relativity. He famously expressed a sense of awe for the order and simplicity underlying nature, often describing a cosmic religious feeling that transcended traditional religious beliefs. For Einstein, science and philosophy were intertwined. Understanding the universe required not only equations and experiments, but also reflection on the nature of reality. His philosophical approach encouraged generations of scientists to consider not just how phenomena occur, but why they occur and what they reveal about the fundamental structure of the cosmos. Einstein's thoughts on determinism and the nature of reality challenged conventional wisdom and provoked deep philosophical debate. While classical physics, such as Newtonian mechanics, emphasized a predictable universe, Einstein recognized that quantum mechanics introduced uncertainty and probabilistic outcomes at the subatomic level, yet He famously resisted the idea that the universe is entirely governed by chance, asserting, "God does not play dice with the universe." This statement reflects his philosophical stance. While he accepted the probabilistic nature of quantum phenomena as a mathematical reality, he remained convinced that deeper underlying laws must exist. His tension with the emerging interpretations of quantum mechanics sparked critical debates with contemporaries such as Niels Bohr, debates that continue to influence discussions on the philosophy of science today. Another significant aspect of Einstein's philosophical outlook was his humanism and ethical awareness. He believed that scientific knowledge carries profound moral responsibilities. In an era marked by political turmoil, 2 world wars, and the development of nuclear weapons, Einstein was acutely aware that scientific discovery could be both a tool for human progress and a potential source of destruction. He actively spoke out against nationalism, militarism, and the misuse of science, advocating for peace, justice, and social responsibility. His letters, essays, and speeches emphasized that understanding the universe should go hand in hand with improving human welfare. This perspective elevated his work beyond mere technical achievement, positioning Einstein as a moral compass for the scientific community and the world at large. Einstein also explored the relationship between intuition, imagination, and logical reasoning in science. He often credited thought experiments, or Jed and Ken experiments, as crucial tools in his discoveries. For example, imagining himself riding alongside a beam of light led to insights that shaped his theory of special relativity. Einstein's philosophy underscored that scientific innovation is not solely the product of rigorous calculation. It also requires creativity, intuition, and the willingness to question assumptions. By emphasizing imagination as a legitimate and essential part of scientific inquiry, Einstein challenged the rigid positivism that dominated much of his era. His approach encouraged a more holistic understanding of knowledge, one that integrates intellect, intuition, and moral reflection. The impact of Einstein's philosophical ideas on society is profound. His insistence on intellectual honesty, curiosity, and ethical responsibility has influenced not only physicists but also thinkers across multiple disciplines, including philosophy, education, and even political thought. Einstein's reflections on freedom, justice, and the role of individuals in society resonate with broader human concerns, reminding us that science does not exist in a vacuum. It operates within cultural, ethical, and philosophical contexts. In this way, Einstein's work serves as a model for integrating scientific inquiry with broader societal values, encouraging a responsible and reflective approach to knowledge. Einstein's philosophy also reshaped our understanding of time, space, and reality itself. Through his theories, he demonstrated that time is not absolute but relative, and that space and time form a dynamic, interconnected fabric. This revelation had profound philosophical implications. It challenged human notions of permanence, causality, and the linearity of events. Philosophers, theologians, and artists drew inspiration from these ideas, exploring new ways to conceptualize existence, memory, and experience. Einstein thus contributed not only to science, but also to the evolution of human thought, expanding the horizons of intellectual exploration. Moreover, Einstein's philosophy emphasized humility in the face of the unknown. Despite his monumental achievements, he remained acutely aware of the limits of human knowledge. He famously remarked, "The more I learn, the more I realize how much I do not know." This recognition of uncertainty and the limits of understanding reflects a philosophical humility that is central to the scientific endeavor. It reminds us that knowledge is a continuous journey, not a fixed destination, and that curiosity and critical thinking are lifelong commitments. In conclusion, the sixth keynote underscores the enduring significance of Einstein's philosophical insights. His reflections on reality, determinism, ethics, imagination, and the responsibilities of knowledge illuminate the deeper dimensions of scientific inquiry. By blending rigorous reasoning with ethical concern and imaginative thinking, Einstein demonstrated that the pursuit of knowledge is both a scientific and humanistic endeavor. His philosophical legacy continues to shape how we think about the universe, our place within it, and the moral obligations that come with understanding it. Einstein's genius was not limited to equations and experiments. It encompassed a profound vision of the universe and humanity, one that challenges us to approach science with curiosity, creativity, and conscience. His ideas remain a guiding light, inspiring scientists and thinkers to seek truth while remaining mindful of the broader impact of their discoveries. Albert Einstein's genius continues to resonate not only in science, but across education, innovation, and the human imagination. The seventh keynote explores how Einstein's life and work have inspired generations of thinkers, reshaped educational practices, and fostered a culture of creativity and intellectual courage. This keynote highlights that the legacy of Einstein is not confined to his equations or discoveries. It lives in the curiosity, perseverance, and imaginative thinking that he instilled in the world, encouraging humanity to explore beyond the visible and challenge the boundaries of knowledge. Einstein's influence on education is profound and multifaceted. He advocated for an approach to learning that emphasizes curiosity, questioning, and independent thought, rather than rote memorization or blind acceptance of authority. He believed that true education should cultivate the ability to think critically, explore new ideas, and connect concepts across disciplines. In classrooms and educational systems inspired by Einsteinian principles, students are encouraged to experiment, hypothesize, and engage with the unknown. This approach not only nurtures scientific talent, but also develops skills that are valuable in any field problem, solving, creativity, and analytical reasoning. By emphasizing curiosity over conformity, Einstein reshaped the philosophy of education, inspiring teachers and learners to value exploration as much as answers. Einstein's life itself serves as a testament to the power of persistence and unconventional thinking. He faced challenges early in his academic career, including difficulties in securing teaching positions and skepticism from established scientists. Yet, his commitment to independent thought and rigorous inquiry never wavered. This perseverance is a critical lesson for students, innovators, and aspiring scientists. Intellectual courage often requires challenging norms, questioning authority, and maintaining focus on one's vision despite obstacles. Einstein's journey demonstrates that breakthroughs are rarely immediate. They are the result of sustained curiosity, resilience, and willingness to embrace uncertainty. In this sense, his life is an educational paradigm, teaching that learning is an active, lifelong process. Einstein's influence on innovation extends far beyond physics. His methods of thought experimentation, conceptual visualization, and interdisciplinary reasoning provide a blueprint for creative problem-solving in fields ranging from engineering to the arts. The process he used to develop relativity, imagining scenarios, questioning assumptions, and applying logical consistency illustrates how abstract thinking can lead to revolutionary insights. Innovators today, whether in technology, medicine, or environmental science, often draw inspiration from these methods. Einstein's approach demonstrates that transformative ideas often originate from thinking differently, combining imagination with rigorous logic, and daring to question accepted truths. His life encourages inventors and scientists to approach challenges with both analytical precision and creative boldness. The inspirational power of Einstein also extends to fostering global scientific collaboration. He championed the free exchange of ideas and international cooperation, recognizing that scientific progress transcends national boundaries. In a world where collaboration accelerates innovation, Einstein's ethos encourages open communication, shared knowledge, and collective problem solving. His correspondence with other leading scientists, participation in international conferences, and advocacy for global scientific institutions exemplify the importance of community in advancing human understanding. By promoting the idea that knowledge is a shared human endeavor, Einstein set a precedent for collaborative research that continues to drive modern scientific achievements. Einstein's contributions to human imagination are equally remarkable. By radically altering our understanding of space, time, and the universe, he expanded the horizons of what humans can conceive. Concepts such as time dilation, the curvature of space-time, and the equivalence of mass and energy challenged the limits of imagination and opened new realms for both science and culture. Artists, writers, and philosophers have drawn inspiration from his work, exploring the interplay of reality, perception, and possibility. In literature, film, and visual arts, Einstein's theories inspire narratives that probe the nature of existence, the experience of time, and the vastness of the cosmos. His impact demonstrates that scientific discovery is not only a tool for knowledge, but also a catalyst for creative expression and philosophical inquiry. Einstein's emphasis on imagination also underscores the human dimension of science. He believed that creativity and intuition are as important as empirical observation and calculation. His famous use of thought experiments, like imagining riding alongside a beam of light, highlights the central role of imagination in scientific progress. This perspective encourages students and researchers to visualize problems in novel ways, to consider unconventional possibilities, and to approach the unknown with an open mind. In essence, Einstein taught that imagination is not merely an artistic pursuit. It is a critical component of intellectual exploration, allowing humans to conceptualize ideas that have yet to be observed or proven. Moreover, Einstein's legacy fosters an ethical and socially conscious approach to innovation. He repeatedly emphasized that scientific and technological advances carry moral responsibilities. The development of nuclear energy, artificial intelligence, and genetic engineering, for instance, must be guided by ethical considerations to ensure that progress benefits humanity rather than causes harm. Einstein's advocacy for peace, justice, and social responsibility reminds innovators and educators alike that knowledge is inseparable from human values. His example encourages a vision of progress that is both intellectually ambitious and morally aware. Einstein's influence continues to shape contemporary education and innovation through initiatives such as STEM programs, interdisciplinary research, and global educational platforms. Curricula inspired by his approach often integrate physics with mathematics, philosophy, and creative problem solving, reflecting his belief in the interconnectedness of knowledge. Research institutions and think tanks encourage students to develop original ideas, conduct independent investigations, and engage with real-world problems, principles deeply rooted in Einstein's philosophy. His life and work serve as a model for cultivating curiosity, critical thinking, and ethical responsibility in the next generation of innovators. In conclusion, the seventh keynote celebrates Einstein's enduring influence on education, innovation, and human imagination. His life exemplifies the transformative power of curiosity, creativity, and persistence. By challenging conventional thinking, promoting intellectual freedom, and emphasizing ethical responsibility, Einstein inspired a holistic approach to knowledge that extends beyond physics into every aspect of human endeavor. His legacy is visible not only in technological breakthroughs and scientific discoveries, but also in the educational philosophies, innovative practices, and imaginative visions that shape the modern world. Einstein's genius continues to illuminate the path for learners, thinkers, and dreamers, reminding humanity that the pursuit of understanding is an endlessly creative, transformative, and profoundly human journey.